Okay, we're given a function, and the function is equal to 4 to the x divided by the quantity 4 to the x plus 2. And I want to find a sum. It's a finite sum, though. It's f of 1/14th, which is not going to be easy to compute, by the way. Oh, by the way, I made a mistake over here. I'm going to correct it. You're not going to see these mistakes, by the way. And I'll tell you what the mistake is over here. This is a mistake over there. It should be 2/14, sorry. That's 2/14. And then 3/14, blah, 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 up to 13/14. The first thing I did was I played around with it, and I couldn't find the sum. And I thought maybe there's a pattern to it. And so sometimes I start to use technology. And I'm not going to say it's the best thing to do, but it's available to us. We should probably think that might be, give us some kind of hint about what to do. Now, the hint I needed to know was, is the sum nice? Or was it some kind of like bizarrely complicated number? So I went to Sage, reset, I typed the function in, and then it said sum it from 1 to 13, all right? And it came back and it said 13/2. And I thought that was remarkable. All right, now I'm looking at this thing over here, and I'm wondering how they get 13/2. And then what I do is I said, at least I know what the sum is. I know the sum over here. At least I know it's 13/2, which is basically just 6.5. All right? So what I did was went to the whiteboard, and I started looking at it, and I want to go through that with you now. All right? So again, the function's this over here, f of x equals 4 to the x over 4 to the x plus 2. The first thing I did with the function was I just simply divided top and bottom by 4 to the x. I want to do that. You would get 1, and let me put this on the side for you. You get 2, and on bottom you get 4 to the x. Now, I certainly want to reduce that. All right, so you get 2 to the first power, and the bottom is going to be 2 to 2x. So I'm going to write this as 2, 1 minus 2x. Now, by the way, this is easier for me to look at. And what I start looking at is I start looking at these, what they want me to do. They want to do f of 1/14th, f of 2/14, f of 3/14. Whoops. I'm going to write them all down, actually. This reminds you of Gauss's story, kind of writing things down and then seeing a pattern to it. And yeah, it does take effort to write things down. I know that. Let me go to the next line. And I'll check to make sure I'm not miscounting anyone. All right, let me count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's actually 13 terms. And so what I want to do is I think I see something. I'm not sure how it's going to work out, but I think I see something. And I'll tell you what I think I see. I see something about this argument here and this argument there. And that would produce, just the two arguments together, just one. And this reminds me of what Gauss did, right? If you know the story with Gauss, he did a sum of 1 to 100. Did it pretty quickly by noticing some patterns over here. And then, 12/14, 2/14. Again, I'm just talking about the argument. That's what the function about. I'm not saying the function, but that also sums to 1. Then 11 and 3 is summed to 1. Let's see, 10 and 4, that's 14/14. So you get the idea. 9 and 5. Let's see, 8 and this, that's 14 and 14s. All right? So what I want to do is I want to kind of look at a pair. And so this is what pair you're going to look at. I'm going to look at f of 1/14th plus f of 13/14. And how am I going to do that? I'm going to plug it in to this thing over here. And let me write that down. It's really not that bad. It's 1 plus, and I'm doing the 1/14th. So you would get 1 minus, well, 2 times 1/14th is 1/7, right? 2 times 1/14th is 1/7. So what do you get there? You get 6/7. Write this down. 2 to the 6/7 plus 1 plus, let me cross this stuff out. All right, I'm going to do 13/14ths now. What are you going to get? Well, you get 1 minus, I'm doing the exponent, by the way. That would be 13/7. Wow, crazy looking number. So that's going to be 7/7 minus 13/7, which is minus 6/7. Well, this is somewhat promising, by the way, but I'm still looking at the denominators are not the same. And what I'm going to do is I'm going to multiply this second fraction by a builder. I want to get rid of the negative exponent. I'm going to multiply top and bottom by 2 to the 6/7. And what do you get there? Well, the first term is just 1 plus 2 to the 6/7. The next term is going to be 2 to the 6/7. Well, 2 to the 6/7 plus, well, if I multiply those two terms together, 2 to the minus 6/7, 2 to 6/7, get 2 to the 0, which is 1. What do I notice now? This and this denominator are identical. Let's add the numerators together. The denominator is going to be 1 plus 2 to the 6/7, and the numerator is 1 plus 2 to the 6/7, which is 1. Right? Kind of remarkable, by the way. But now I'm starting to wonder, should I do the other ones now? Or can I just simply get a general pattern to it? So what I want to do is I want to write down what I think is a general pattern. I'm going to write down f of n plus f of 1 minus n. And really what I'm saying is that I'm looking at this over here, and the sum of their arguments and 1 minus n would be 1. That's what we saw before, by the way. I want to write it down now. Again, I'm using the same formula. 1 plus, I want to remind you what that formula is. It's right over here. Let's put the n in, which can be 2, and you can get 1 minus 2n. Plus, it's a little more complicated. So it's 1 plus, I got to do that exponent again, but now it's going to be 1 minus n. So I'm going to put this over here. So it's going to be 1 minus 2, 1 minus n. What do you get there? 1 minus 2 plus 2n, which would be 2n minus 1. Write that down. Well, I'm seeing the pattern, and I might just verify, make sure it's true. I can multiply top and bottom by 2 to the 1 minus 2n. 2 to the 1 minus 2n. Let's put that down now. The first term is 1 plus 2, 1 minus 2n, plus, well, the top's easy to multiply together. It's going to be 1 times 2 to the 1 minus 2n. On the bottom, 1 times that is 2 to the 1 minus 2n, plus, now if you look at these exponents over here, this whole point of doing it, they sum to 0, and 2 to the 0 is just 1. So I'm left with a generalized pattern, and I'll put this over here for you. And you get 1 plus 2 to the 1 minus 2n, which is 1. So I want to just go up here and just simply say, how many of those pairs that I have, right? Now remember, we paired these with these, and I got 6 pairs, by the way. And every one of those pairs, and I say that, when I match this one to this one to that one, so forth and so on, they're all going to produce a 1. So I'm going to say the sum, and let me just write that down again, n equals 1 to 13 f of n over 14. Well, what did I get? I got the 6 pairs, but I have somebody left over. And who do I left over? This over here, f to the 7/14. Well, I don't know what that is. I got to figure that out now. I'm going to put this down. So it's going to be 6 plus, let's see, we got 1 plus, well, I want to point out, I'm really doing the exponent, which is going to be, it's going to be 2, but the exponent's going to be 1 minus, well, 2 times that number. And that's going to be 14/14, which is 1. And what would that give me? 2 to the 0, which is 1. So what do you get? I get 6 plus 1/2. What's 6 plus 1/2? That's going to be 13 over 2. Exactly what Sage got. Now, I realize some people are saying, let's go back to that. How does Sage do that? I'm no expert in how Sage does things, but my suspicion what Sage does, it actually does brute force. All right? Now, what do I mean by brute force? It actually computes numerically. When I say numerically, a nice answer for each one of these things, adds them together, and it gets this over here. All right? Now, granted, this could be extended to even larger numbers, but the bottom line is you got a finite case over here. You could extend this on and see what you come up with. But again, did we get the same thing Sage got? Yes, we did. I put the work down for you. I type it up for you. I'm hoping there's no errors in the work. But the bottom line, you look at the work, and if you see an error, please bring it to my attention. Right, I do need to correct something over here. I need to correct this over here, and I will correct that. But again, I thank you for paying attention. I do appreciate it.